Hi guys. So today we are going to discuss OOW stability, July 2023, question 1. So let's start. So question 1, a vessel is upright, port side alongside in salt water. A 96-ton heavy lift is to be loaded from the quayside using the vessel's crane. Present condition, even keel draft 4.40 meter. kg is given 8.59 meter. Height of crane above the keel is 22.8 meter. The weight on the quayside is 20.75 meter from the center line of the vessel. Prior to loading the heavy lift, the vessel is to be listed 5 degrees to starboard by transferring ballast from a port side double bottom tank, initially full, to an empty starboard side double bottom tank to a distance of 14.16 meter. The transfer of the ballast will introduce a total of 446 tons meter of free surface moments. Using hydrostatic datasheet particulars, calculate each of the following. The weight of ballast to transfer to create the required list. The angle of list when the heavy lift is first picked up and suspended over the quay. Note, assume no change in kg of vessel due to any vertical component of shift of weight of the ballast. So let's answer part A of this question. So for answering part A, so what they want us to do is that the ship should be initially listed 5 degree to starboard before we do the heavy lift operation. So in order to make the ship 5 degree starboard, we need to transfer some amount of ballast from port side to starboard side, the ballast tank. So that distance between this ballast tank is 14.16 meter. So we have to calculate how much quantity of water should be transferred from the port side to starboard side. So in order to do this, let's consider. Let's take this details from the data given. So it's given in the question that the draft in salt water is 4.40 meter for the vessel. So with that draft, if you go to the hydrostatic particulars, you will get the displacement as 8768 for the salt water. And for the same value, you will get from the hydrostatic particulars, Km is equal to 9.49 meter. And the kg is already given in the question. So you have kg 8.59, which is given in the question. So with this data, you can find the GM. So GM is Km minus kg, and that will give you GM is 0.90 meter. And by transferring this ballast from port side to starboard side, and the port side tank was initially full, and now when you transfer, there is little bit of water in both the tanks. So this will create some free surface. So this free surface moment is already pre-calculated and has been given in the question paper. So that is FSM is equal to 446 tons meter. Now, in order to calculate the FSC, free surface correction, FSC is equal to FSM divided by the displacement. So that will give you the FSC, free surface correction, as 0.05 meter. So now you need to calculate the GM fluid. So the GM fluid is GM minus free surface correction. So that is 0.9 minus 0.05, and now we will get the GM fluid, that is 0.85 meter. Now coming to the main formula, that is tan theta. That means tan theta is equal to listing moment by displacement into GM. So this formula you will get from the formula sheet, and replacing the values, tan theta is equal to listing moment is W into D. That means W is the weight transferred and D is the distance transferred. So you need to find this W. Rest all values are known to us. So in order to calculate the W, you have to put all other values. So the list should be 5 degrees. So you have to put tan phi degree is equal to W into the distance. D is the distance traveled, distance that has to be transferred between two ballast tanks. So that is 14.16. So W into 14.16 divided by displacement into GM. GM we have already pre-calculated, that is 0.85 meter. When you calculate it, you will get W. W is 46 ton. So this is the answer for part A. So that is 46 tons of ballast need to be transferred from port side to starboard side in order to create a list of 5-degree starboard. That's the answer for part A. Yeah, so now let's come to the section B of the question. So section B, you need to find the angle of list when the heavy lift is first picked up and suspended over the key. So that means you are lifting a weight which is on the port side. You are lifting a weight which is on the port side by using a crane, and the distance from the center line of the vessel to the quayside is 20.75 meter. So let's see what will happen. So now we have to calculate the angle. So the ship is already, we have already made a list of 5 degree to starboard, and now with that existing list, we are picking up the weight from port side, and we have to see how much is uh, the list in the end when you lift up the weight. So for first of all, you need to create a table like this, and you need to enter. So the ship's weight is that means the displacement is 8768, and the kg which is already given in the question, and you will get the moment. So if you multiply weight by kg, you will get the moment, and then you are adding a weight of 96 ton, and this kg is the height of the uh, this 22.80 is the height uh, uh, of the crane above the key. So that's kg, and you will calculate the moment. So that will give you 2189. That is the moment, and then the free surface moment that is already given in the question, that is 446. So you have to add up all these, and you will get a value 77952. And then when you add displacement, you will get 8864. This is the new displacement of the vessel. Now to find the final fluid kg, that will, so moments divided by weight, that will give you final fluid kg is 8.79 meter. Now you need to find the final km. In order to find the final km, you need to go to the hydrostatic particulars, and then you have to interpolate the values. So you have to look for this way 8864, and then you have to go to hydrostatic particulars, and then you need to obtain the value for km. So once you obtain the value for km, you have to find what is the fluid, GM fluid. So GM fluid is equal to km minus kg. So that will give you 0.66 meter. So this is your final fluid GM. So from part A, we have, if you refer back to part A, you you will get, you have already calculated in the end, if you see, by using this method, tan 5 degree into displacement into 0.85, here you have already calculated the listing moment, which we have already, the ship was initially listed to starboard. So that listing moment is equal to 652 tons meter to starboard. This is the initial listing moment that we are having. Now we are calculating the port side listing moment when lifting weight. So that can be calculated by the weight into distance from the center line. So 96 into 20.75, that will give you 1992 tons meter to port. So this is the listing moment that has been created while lifting this weight. Now the resultant listing moment, that means whichever is higher, you have to subtract the lower one from the higher one. So while doing that, you will get 1992 minus 652, that will give you 1340 tons meter to the port, because the port side one is bigger, port side value is bigger. So that's why the listing moment, effective listing moment will be to the port side. And now you have to put up this into the formula. So tan theta is equal to, you have to find the list, tan theta is equal to listing moment by displacement into GM. So listing moment, resultant listing moment, you already got 1340 divided by displacement into GM. So when you calculate that by using the scientific calculator, you will get the final list as 12.9 degree report. So uh, this is the list that will be created when you pick up the weight which is on the key side. So that's the answer for this one. Okay, thank you. Bye bye.